Hello, Moto. Today, my little robots, we're going to be talking about class attributes, class methods, and property getters and setters in Python. That is all. That's what we're doing today. We're going to do this fast because this is fundamental information and we just got to know it. And I believe that we need to know it in a quick way, aka how to do it and a little bit of why to do it. So let's get into it. All right. So the very first thing you want to do to create a class attribute is to set it here. Outside of any method in the class, should be top level of every method in the class, this variable that you set. And this variable that you set will be accessible in the class itself as a class attribute. It will be available to all the different methods that you define inside of the class. Top level, meaning that when you reference it, you have to reference it with the class itself, because this is not self, this is class. All right, cool. Call this class attribute initial flavor. Set the initial flavor to cherry. I don't like cherry ice cream, I like cherry icy, but you know, for the purposes of this video, I like cherry flavored ice cream. Alright, so flavor, we're going to set the flavor. So do we need any other attributes? You know what? I don't really care to add another attribute because this is just to show what's possible here. Alright, cool. So we have the class attribute, and then we have the constructor, and we're passing flavor into the constructor. So meaning every time we instantiate ice cream, we're going to have to pass in flavor. Alright, cool. Let's access the class attribute. So let's say self dot initial. I'm gonna make it instance attribute that will reference the class attribute initial, and we'll say ice cream dot initial flavor. So we're gonna instantiate and the flavor that we're gonna pass in is chocolate, but we want to see if the initial flavor is actually on here. So yeah, guys. So the initial flavor is actually accessible from the instance object by just calling the attribute that we put on the instance object called initial flavor, and it will reference the class attribute. Yeah, so that's how you set up, like create your little class attribute, and then this is how you reference the class attribute, and it can be used anywhere in the class. All right, so let's go. So what's something that we can do to like kind of extract this a little bit? I think a good way to abstract this a little bit, instead of putting it on here, I would put it in a getter and a setter. So if you're going to use getters in Python classes, it is highly recommended that you use something called the at property decorator. At property decorator has a very interesting syntax. Let's check this out. All right, so we're gonna call it define get initial self, and then we're gonna return ice cream dot initial flavor. right? And so this, we're going to expose this as an at property, which is a getter. It's just a getter. All right, so we're going to return the ice cream's initial flavor, and then what we're going to do is, I believe we could just call it real quick, ice cream dot get initial. Let's see. Ice cream object has no attribute get initial. Ice cream get initial. Ah, I spelled it wrong. All right, cool. Let's see. Okay. Do that. Now can you set a value in there? So ice cream dot get initial. So you see how I named it? I named it as get initial. So that's like an action. That's like a verb or whatever. Being that is a property of the instance object, it would probably be better to not name it as a verb and to name it as just like a noun. It kind of goes in line with what it does. It's just a property on the ice cream itself. It's only saying what it I don't know. It's just describing a part of the ice cream. So let's say we remove that and just say initial, or actually even better, initial flavor, right? Because this is what it was the initial flavor. So we're going to call it initial flavor, and then we're going to then do this, initial flavor. It's no longer returning. Why? I bet you it is returning. It's just REPL. Quite interesting. All I did was change the name, and what happened there? All right, and if I change it back to get flavor, well, initial flavor or something like that. Let's see. Let's see what happens, guys. This is interesting. I'm always learning something different. Whoa. Okay. I think I see what's happening. So it's some sort of a name collision is happening and it's returning you the property. And that's pretty much it. So make sure that you name your property, not the name of the thing that you're returning. That's pretty much it. All right, cool. So now let's see if can we add something here to this get flavor. No, we can't. Let's see. Attribute error, can't set attribute. So basically what's happening there is this is a property getter, and what we need is a setter in order to set a new value to the attribute. So define set flavor self val, and then we're going to then say, okay, I'm just going to put pass right there and kind of like think it through as I go. All right, so what we're going to do then is then we're going to use this syntax, at, and then the name of the property that we'd originally set as the getter, get flavor, and that will be the decorator, and then we'll just call dot setter on the decorator for get flavor. So now this is a setter method, a property setter. So we have that. And then what I'm going to do is I'm going to ice cream dot initial flavor, because we're going to be changing the flavor. We're going to set the new flavor to val, and we're going to return that, I guess. Cool. So the new flavor is this. Now we can do ice cream get flavor as, nope, we have to reference it as set flavor, because that's the name of the method, the method that we created. Set flavor vanilla, and then we're going to just set it real quick. Okay, maybe the return is the part. Is the invalid thing? Ice cream, okay, dot initial flavor is equal to val. Okay, that doesn't blow up, so then that means that it works. So now let's see what happens when we access get flavor. Is it going to give us the new flavor, or is it going to give us the old flavor that we had? Ah, new flavor, vanilla. Okay, so how did that work? So two-step, well, I guess two-step process. So you set the getter first with at property. You name it. You set up the body. Boom. Then when you're creating the setter, you just reference the name of the getter as the decorator and call dot setter on it, and then that's enough to tell Python that this is a setter. All right, so that's pretty much it. That's it. All right, next steps. So we're going to be going into what are class methods. To create a class method in Python is fairly simple. All that you need to do is just call at class method decorator. That's pretty much it. So what would be, so define, I don't know, container. Define container, pass. So this container is going to be a static method. I know you guys thought I was going to say class method, but I'm not. I'm going to call it a static method. So in Python, there are two different ways to create class methods, and they both give you different benefits. That's why there are two different methods. So I'm assuming that the static method thing is a really old school way of creating class methods, kind of being inherited from other languages, and Python just kind of like picked it up or whatever. But static method is a class method, and a class method is just something that exists on the class itself, not on the instance object of the class. So it means that it's state for all of the objects of the class. That's what it's pretty much setting up. And then in this case, we're going to set it to be an ice cream cone. That's what this container method is. It could be either a cone or a cup. What's happening here that you don't see quite yet, and I guess it will be more clear when I write it out, is that you see this container val. The class method container takes a value, and that's pretty much it. How is this a class method? It's never really clear, at least not to me. But a clearer way to write a class method in Python is to use the actual class method, decorator. So then we're just going to create this and then it actually takes the class, the reference to the class. So instead of calling self like you do for most methods in Python, you in this case will call CLS, and then pass it the value that you want. And then that's pretty much it. That's how you write the class method. So let's do something a little bit more interesting. So in the class method, we'll change the class attribute, or we'll create another class attribute. We're going to call this not container. We're going to call it containment, so we don't get into any type of naming collisions or whatever. And containment is going to be an array, and the array can contain either cone or cup, since those are the only two that we know will be able to contain ice cream. So in the static method and this class method of the same name, I do not know if they could exist both at the same time like this. So I will be changing the name. Yeah. So in the container, let's say I'm going to use the class method first, since I think it's a lot more useful, really. Dang, I didn't know I had a prejudice against the static method, but I do. I need to learn more about it. So CLS, this is why it's quite interesting. CLS dot if val is not in CLS dot containment raise value error must be clone or cut. If that returns, then we just do an else. We'll say that we'll set it. So so I would be able to do this CLS dot, hold on, can't really see it. All right, so I would be able to do this. What I'd say is that containing it is equal to now a new value, which would be the value that is set, but that would override the fact that we already had some information here. So the class attribute will be overridden, and it will be set a specific value. So what that leads me to believe is that I need to change the name of this, reference it for, I need to change the name of it and reference it as a read-only property. So I'm gonna name it containers. So clever. Containers. Oh, actually, no. Better yet, container type. That's it. And then I'm going to create a, all right, CLS.containment. Actually, CLS.containment type. This is like CLS.container type raise value must be clone cut, and then CLS.container. Set it equal to val, or rather self dot and actually, since I'm referencing it on self now, I'm gonna have to change that up. So anyway, dang, what's a good way to do this, guys? I don't know. I could just make it an empty string as a class attribute, and then say, like, let's say that this ice cream thing is like this giant manufacturer, and you set it one time, and that's why it makes sense to call it a class, use it in a class method or whatever. So we'll be like, initial container is equal to like an empty string. And then this initial container class attribute, we'll be changing it to this value. And that should be that. We could write the same logic that we have here for the class method inside of the static method. It would do pretty much the same thing. The only difference here is that we need to change the CLS, because we don't have access to the CLS in the static method. We have to actually use the actual name of the class. So it would be this: if val not in, and then we call this ice cream dot container type, and then here also same thing, ice cream dot initial container equals val, and that's basically how that would work. There's not much of a big giant difference between the two things. They're the same thing. They just have different references to how they reference the class. Yeah, that's pretty much it. All right, so now that we have this, let's run this bad boy. We gotta make sure that it works, right? We definitely gotta make sure that should happen, because this is crazy out here. All right, we're gonna reference. So we didn't set container yet. So, and then we already have an ice cream instance object here. This is really getting in the way. We have an ice cream instance object here. And what do we want to do? We want to, that is probably, do I have access to container here? Set it as waffle. So to blow up, and we'll see that it doesn't work exactly how we wanted it to. Value error must be cone cup. All right, cool. That's what we thought. That's what we expected. We're gonna set it as a cone. So it works. We just didn't set up any type of like validation that it worked. So we expect it to work if we say then ice cream dot initial container. Remember, it was an empty string, so this should not be an empty string that gets returned. In this case, it should be cone. So yeah, that worked, and that was it. that was pretty much all. Nothing crazy there. Oh, let me talk about this calling super init. This right here. So when I first started, I saw this everywhere, and I was just confounded by it. What is this? So it turns out in Python, inheritance, having like subclasses and base classes, and you have methods with the same name in the subclass as it has in the base class. Python won't call the base class method. It won't do it. It will call the subclass method. If you're using certain libraries in Python, they will always say that you can override this method here. However, you have to use this syntax to override it. So what this is saying is invoke the base class method and then the method name, and then pass whatever args, quargs you need to pass in to the method on the base class into that method. So invoke this base class method, pass these values to this method, then return it back to me. That's pretty much it. That's all this thing is doing. That right there, and then there's a really good definition of exactly what that is I'll just read it to you real quick, and then after that we can just call it a wrap here. Unlike other object-oriented languages, where constructors at every level in an inheritance hierarchy will be called automatically, the same cannot be said for initializers in Python. If we want a base class initializer to be called, when we override that initializer in a derived class, we must do so explicitly. Remember, explicit is better than implicit. If we want a base class initializer, like I said, init, if we want this to be called on the base class, if we want to override that, we have to call this in order to override that. Otherwise, the overriding is not going to occur. You're going to write your thing, you're going to think it works, and it's just not going to work. It's going to blow up. And this is the syntax that enables it to actually do the proper overriding that you want. That's it. That is pretty much it. Alright guys, so that's it for me. This video came out a lot longer than what I expected it to. Hopefully the next one will be I guess shorter. Anyway, peace.